Hi guys, and welcome back to my channel. Today we're going to learn how to build a custom neural network in Python from scratch. Neural networks are in high demand because of their many applications from computer vision to big data analysis. It may be daunting to enter into this facet of software engineering, but it's actually extremely easy to get started. We're going to start by building a very easy neural network called a perceptron. A perceptron is a single-layer neural network with no hidden layers designed to do a specific task. A perceptron consists of 4 pieces: the input layer, the weights and biases, the net sum, and the activation function. The input layer is the data that you're feeding to your neural network to either train or test it. The weights are the strength of a particular node, and the bias allows you to move the activation function curve up or down. The net sum is the sum of the weights and biases, and the activation function is used to map our input to the required output. So let's just jump right into the code. Okay, we're going to start by importing NumPy as NP to manipulate our arrays. Next, we're going to start the perceptron neural network class. Then we're going to define our initialize function. So I'm just going to add a pass here. Before we create a neural network, we need to set up our data. Let's create the standard if name clause to create our training input and our training output. The training input will consist of 4 examples consisting of 3 input values that are mapped to 1 output value in the training output. Okay, now that we set the training input and output, we can head back to the initialize function of the perceptron neural network class, and we're going to seed our NumPy library. Now we're going to use the NumPy library to create a 3x1 matrix consisting of values between -1 and 1. Next, we're going to create our activation function, the sigmoid function. Many of you may know, but for those who don't, the sigmoid function maps any value between 0 and 1. Next, we're going to create a sigmoid derivative function to adjust our weight values during training. Okay, so our perceptron neural network is almost done. Now what we need to do is create a training definition and a testing definition. So let's just do it right now. We will start with the test function that will take our inputs and make predictions based on the current weights and bias. We will then use that data to further train our neural network. So what we're going to do here is we're going to use NumPy to create a dot product of the inputs and the current weights, and then use the sigmoid function to normalize the values. Okay, we finished our test function. Now let's move on to the training function. To create the training function, we're going to need to be prepared to get the training inputs, the training outputs, and the iterations, or the amount of times you want to loop through the training data in order for your neural network to learn. We're going to start with a loop function with the range of iterations that we've passed to our training function. Generally, the more iterations you have, the more accurate your neural network becomes, but depending on how large your data set is, you might want to tinker with this number. You don't want a small iteration size because that'll lead to faulty tests, and you don't want a large iteration size because that would be overtraining your network, which is very time consuming. First, we're going to receive an output given the current weights and bias that we already have in our neural network. Now we're going to calculate the error between our output and the output that we gave to our neural network. Now we're going to calculate the adjustments using a NumPy dot product between our training inputs, the error, and the output of our sigmoid derivative. Now we're going to append our synaptic weights with the new adjustments. Alright, there you have it. We finished writing out our perceptron neural network. So let's test it out. Let's see how well we did. First, we're going to start by training the network. I'm going to use 50,000 iterations. I found that actually works best for a neural network of this size and caliber, so we don't have to go to 1 million or 2 million. We'll stick with 50,000, which is very quick. So after the neural network is done training, we are going to print out the current synaptic weights. So we have our training inputs and our training outputs, but let's create some testing data. Okay, so our testing input is going to be a NumPy array consisting of 0, 1, 1, which is the last value of our training inputs. So after training, we should test it and get an output value very, very close to 0. So let's see, testing input equals NP Okay, so we're going to go back down here after I print the synaptic weights, and we are going to test our neural network. Perceptron neural.test. We're going to pass it the testing input. Result. Then we're going to print the result. Okay, so before I run this, I'm actually just going to edit this print function a little bit to make everything a little bit more legible. So we're going to run it first without the result, and let's see what happens. So we get our synaptic weights here. First one is 11, and negative 0.2, and negative 5.4. So these are what we end up with. If you run it again, this is the same. Okay, so now let's clear this, and let's see our result. After we trained it 50,000 times, our result should end up very, very close to 0 because that's the output of 0, 1, 1. So let's see. And there we go. Our output is 0.003, which means we've successfully trained our neural network, and we can test this again. Let's try 1, 1, 1. The output should be 1. If I just change this number here. Very close, 0.99. And if we increase the iterations on our neural network, to 100,000 instead of 50,000, this number should be closer to 1. So let's see. Yes, it is. So instead of 0.996, it is 0.997. Alright guys, there you have it. We have built a perceptron neural network very easily in Python from scratch. I hope you liked this video. Please hit the like button and don't forget to subscribe, and I'll see you in the next one.